Okay, section 1.5, combination of functions. The first 3, maybe 4, depending on how you look at it, you have done in integrated 1. It was integrated 3, it was the first essential skill. So we have given you equation f of x on the left side over here and equation g of x. And we've asked you to do all the possible combinations. So I'm going to do my work over here. 1a, I'm going to call it. If we do f plus g of x, notice we could write it like that, or we could write it like f of x plus g of x. It means the same thing. I'm going to take equation f, 3x minus 1, and add equation g, 2x plus 5. Technically, for addition, the parentheses don't do anything, so it's literally combining like terms. 3x plus 2x is 5x, negative 1 plus 5 is 4. The answer to 1a gives you 5x plus 4. 1b is subtraction. I'm just going to write it one way from now on. I'm going to switch which way, but I'm not going to write it both ways. Subtraction, the parentheses do matter. Equation f first minus equation g. Parentheses matter because you need to distribute the negative sign. This is the most common mistake. First one stays the same. Minus 2x minus 5. Combine like terms. 3x minus 2x. Negative 1 minus 5. This is the answer to f minus g of x. Next is multiplication. And the ways you can write it is written here, right? All the different ways we could write the equation. 2. I'm going to do 2 over here so I can have enough space. We are doing f times g. Multiplication, you can just write the letters next to each other, of x. So I'm taking equation f and multiplying it by equation g. Multiplication, most of you do an area diagram. So 3x minus 1 on one side of the box, 2x plus 5 on the other. Multiply it out. I get 6x squared plus 13x minus 5 for my answer. The last of the first 4, right? I'm calling it 4 because 1a and b is division. Number 3. F of x divided by g of x. Equation f on top. Equation g on the bottom. But, super important, that's not highlighter, we need to make sure we include the restriction. And again, you did this last year. You take the bottom off to the side. I like to write aside usually when I do work on the side. You take the bottom and you set it not equal to 0 because we can't divide by 0. So whatever the bottom is can't equal 0. And you solve for what x can't equal. X can't equal negative 5 halves. So up here at my answer, you put a comma. X can't equal negative 5 halves. This whole thing is the answer. Add, subtract, multiply, divide. The last one is composition. Number 2, it's asking us to do, so I'm looking here, the same equations, f of g of x and g of f of x. I'm going to need a new page. Give me 1 second. Okay, hopefully you have enough room on your paper. So we're going to do, this was 2 technically, f of g of x. That's one way we can write it. Or f of g of x is another way we can write it. Either way, we're doing the same thing here. That means you're going to take equation g. You start on the left. You're going to take equation g and you're going to plug it into equation f. So maybe I should highlight these. Take equation g and plug it into equation f. So we are going to have 3, because I'm starting with equation f, but instead of an x, I'm going to plug in 2x plus 5 minus 1. So once I've done it, hopefully you can see equation g is inside equation f, and then we simplify it. Distribute. f of g of x is 6x plus 14. B wants us to do it the other way. G of f of x, or g, it's a little floating circle of f of x. That means we're going to take equation f and plug it into equation g. So I start with the g, 2, but instead of an x, I'm going to plug in equation f. Again, once it's written, hopefully you can see f is inside of g. Distribute and simplify. Notice you get 2 different answers. That's 3, not 4. 2 different answers, because the order that you compose, this is called composition, changes the answer. So make sure you realize, unless there's a very special case where you get the same answer, otherwise you will get different answers. Okay, so what about visually given the graphs? So f plus g, we can do them one at a time. We can find f of negative 1, because this is the same thing as f of negative 1 plus g of negative 1. So to find f of negative 1, that means x is negative 1. Find that on the x-axis. They want to know, what does the equation equal? Well, the equation has a y value of 1 there, so this answer is 1. And then, well, what about g of negative 1? Negative 1 on the x value. Find the y value. What is that, 3? G of negative 1 is 3. And now add them together, and you get an answer of 4. So find each piece and then do the math. So this is f of 1 minus g of 1. So find f of 1, go to the 1, trace it down to the y value, you get negative 1. Problem says minus. Now find g of 1. Happens to be positive 1. Negative 1 minus 1 is negative 2. Number 3, or C, I guess. F times g of negative 2. So find f of negative 2, find g of negative 2, and then multiply them together. I got 8. Hopefully you see where I got those numbers from. The next one has the of circle, f of g of 3, or, sorry, I'm in shapes. F of g of 3. So first we do the inside parentheses. We find g of 3. 1, 2, 3. The answer is negative 1. Now we do f of negative 1. We've already done that once. The answer is 1. So your final answer is 1. So using the graphs to find the different combinations of the functions. Okay. You're building a fence in your backyard. It will touch your house, so you only need 3 sides. It will make a rectangle. You have 100 feet of fence. Write an equation for the area of the yard you enclosed in terms of x. We will do a lot of these, especially first semester, so let's start with a picture of what they are talking about. So you live in a house, and then you are building a fence, but one side is going to be touching your house. So you only need your fence to go like this, and it says it makes a rectangle. So the purple is my fence. You have 100 feet of fence, so let's label this some more. This is the house. This is the yard. When you have 2 sides that match, it's easier if you call those x. So, like, I could call this x and call this y, but then I'd have 2 y's, and you never really want 2 y's in math. So I'm going to call this x, because they have to match. It's a rectangle. This would be some other measurement, so I'm going to use y. So we know it touches your house, so you only need 3 sides. It will make a rectangle. We got that in our picture. If you have 100 feet of fence, so what do we know, based on my purple, about having 100 feet of fence? Well, we know the fence, 2x plus y, right? That's x plus y, has to equal 100. It's assuming you're going to use all your fence. So 2x plus y equals 100. That's what they told me about. I have 100 feet of fence. Well, if I solve that for y minus the 2x, y is going to equal 100 minus 2x. It's always better if your labels have the same variable. So in my picture, I'm going to erase the y, and I'm going to write 100 minus 2x there, because that's how much fence I have. That's what y equals. Then it says, write an equation for the area of the yard. So area is x times y normally, right? Area in terms of x, no, just area equals x times y. But since I have both sides in terms of x, it's x times 100 minus 2x, right? You can look at the picture. Length times width, that's how you get area. And then that's the equation in terms of x. I don't need to do anything else to that. That's the answer. There's no need to distribute or simplify or anything else. Okay, then it says, what's an appropriate domain? So we need to think about context in this problem, right? So if x represents the length of the yard, so here's my x right here. In order to even have a backyard, what's the smallest x could be? Well, it can't be 0, but it could be really, really close to 0, right? You could have a tiny, tiny, tiny backyard. So the way we write really, really close to in math is by writing a parentheses 0, right? Anything bigger than 0 would work, and that would make sure that I have a width to my yard. Well, I also need to make sure that I have a height to my yard. So I need to make sure this doesn't go less than 0. So 100 minus 2x, sorry. We want to make sure that 100 minus 2x doesn't equal 0, or I guess we want to say is greater or equal to 0. So solve it minus the, I'm going to add the 2x. You could probably just figure this out by looking at it, right? X has to be greater or equal to 50. Sorry, x is less than or equal to 50. 50 is greater or equal to x. So the biggest it can be is 50. I mean, just look at it. If I plugged 50 in right there, it would make 0. You probably could have done that without me writing an equation at all. So anything from 0 to 50, but it can't actually be 0 because then I wouldn't have a backyard. It can't actually be 50 because then I wouldn't have a backyard. Okay, you don't get or need a graphing calculator in order to do this. So let's look at our graph here. So you could distribute this if you wanted to make it look more familiar. If you distribute that, you get a of x equals 100x minus 2x squared, which is going to be a parabola. And we know the domain is from 0 to 50. So I can just draw, it's upside down because it's negative 2x, right? From 0 to 50. Where's the vertex? They want us to maximize the area. This represents the area. The vertex is going to be right in the middle. The vertex is going to be at 25 comma something. So the dimensions of the yard, the dimensions of the largest yard, it's going to be when x equals 25. So my dimensions, remember up above circled in red and orange, my dimensions are going to be x equals 25 because I found the vertex, but I need to plug in 25 to find the other side, the y side. 100 minus 2 times 25, or 100 minus 50, which is 50. So my y is 50. So my yard is 25 by 50. Okay, we will practice more of this together in class, and I hope you're doing well.